Today we're going to review some different pieces of statistics, and so we're going to start with the 5-number summary. The 5-number summary is made up of your minimum, your quartile 1, sometimes this is referred to as your lower quartile, your median, quartile 3, sometimes referred to as the upper quartile, and then your maximum. So we're going to look at how to find these using your calculators. We're going to use this following set of data, and we're going to start by entering that data into your calculator by pressing the Stat button and then clicking Enter on Edit. You're then going to quit out of that screen by pressing Second and then Mode, and then you'll go to Calculate Statistics, and then you're going to calculate your statistics by hitting Stat, and then go to the Calc menu on that, and then hit 1 var Stats. The first option will be your list, which is L1. You'll leave your frequency list blank, and then you're going to press Enter on Calculate. You're going to scroll down, and you're going to find your min, where it says Min X, Q1, Median, Q3, and Max X. And so you're going to find that your Min X is 0.57. Your quartile 1 is 0.675. Your median was 0.78. Your quartile 3 was 0.93. And your max was 1.37. If you didn't get those values, you're going to want to double check that you entered all of these data points in. So next is our interquartile range, and so that's just taking your third quartile minus your first quartile, so 0.94 minus 0.675, and when you do that, you're going to get 0.265. Next we have outliers, and so to find the outliers, to find your lower outliers, which is right here, you're going to use that formula, and to find your upper outliers, you're going to use the bottom formula. So we're going to do quartile 1, so 0.675 minus 1.5 times our interquartile range, so 0.265, and you'll type that into your calculator, and when you do, you're going to get 0.2775. Then we're going to find our upper outlier. So then we're going to do 0.94 because that's our third quartile plus 1.5 times our interquartile range. And when you do that, you're going to get 1.3375. And so if any data values fall outside of the numbers above, then you will have outliers. If all of the data values fall inside of the numbers above, then you will have no outliers. And so it's important to make a note that if you look at your upper value, it's 1.3375, and then if you go to your maximum value, it's 1.37, which is outside of that. So we actually will have, for this data set, an outlier, that was spelled wrong, an outlier at 1.37. Now we're going to use this information to create a box and whisker plot. So we're going to start, we always want to draw a line for our number line, and then we're going to do some tally marks on there. And so you want to put the median just kind of somewhere around the middle, and so I'm just going to count by tenths, and so I'm going to start with 0.8 in the middle, so then 0.9, 1.0, 1.1, 1.2, 1.3, and 1.4, and then we have 0.7, 0.6, 0.5, 0.4, 0.3, and now we're going to draw our box and whisker plot. So we're going to actually use our 5-number summary to do this, and so our minimum value is at 0.57, so we're going to approximate where that is, and we're going to put a dot above it. And then we have go to our quartile 1, which is at 0.675, so we're going to approximate where that is, and we're actually going to draw a line above that. And then we're going to go to our median at 0.78 and draw a line above where that would be. And then we're going to go to our quartile 3 at 0.94 and draw a line above where that would be. We connect these 3 lines here to create a box. We connect our dot out here to the box. And then we go, our maximum value is actually an outlier. So what we're going to do is we're going to use our number up here, 1.3375, as our point that we're going to go to. But then we need to draw our outlier of 1.37 in here, so we're going to put a star right there for our outlier. And so if you want to label this, this was our minimum, this was quartile 1, our median, quartile 3, and then this was our maximum out here because it was an outlier. And this is our our outlier boundary. Okay, so now we're going to look at spread of data, and so we're going to use, okay, you're going to find these using your calculator and using the same data we just used. So you go back into this right here where we did the 1 var stat, we need that again. And we're going to find our mean. And so our mean is going to be, when you're talking about a sample, it's x bar, which is an x with a line over it. And that's what your calculator actually shows. So it's 0.818. And in your calculator, so when you're talking about a population, you use this fancy looking m, which is a mu, and your calculator actually does not distinguish between the two. And so when you're using your calculator, you cannot distinguish between the two. You just need to be able to, you just need to remember that that's what it would mean. Alright, so then our range is our maximum minus our minimum. So in the calculator, we're using the max x minus min x. And so it's going to be 1.37 minus 0.57, and that gives us 0.8 as a range. Our standard deviation when talking about a sample is the SX, and so that's 0.194. And if we were talking about a population, it's that symbol, which is actually a sigma x, so then that's 0.191. Now to find our mode, we're going to use our calculator, and we're going to sort the list of data from smallest to largest by pressing the stat button, going to where it says sort A with a parenthesis, and then hitting second, and then 1, and then the enter button. And then we're going to view our list by going from to stat and then edit, and then you're going to look for repeated numbers and keep track of how many of them repeat. And so we find that 0.59 repeats 2 times, 0.68 repeats 2 times, 0.76 repeats 2 times, 0.8 repeats 2 times, and 1.03 repeats 2 times. So the number or numbers that repeat the most is or are the mode or modes of the data. So you can have more than one mode. So all of these repeat 2 times, so they're actually all the mode of our data. And so we're going to write that the mode is all of these numbers that we found above.